Okay, and some more proofs from the worksheet number 4. And number 5, we're given that C is the midpoint of AD, C is the midpoint of BD. And we want to prove that angle A is congruent to angle E. So as usual, we're going to try to find there's angle A and there's angle E. So we're going to try to find two triangles that those are parts of and show that we have enough information, or hopefully we'll have enough information to show that these two triangles are congruent. Therefore, these two angles will be congruent because they'll be corresponding parts of these two triangles. Okay? So let's get to work. And we have C is the midpoint of AE, that's given. And if C is the midpoint of AE, remember midpoint divides a segment into two congruent segments. So if C is the midpoint of AE, I know that AC is congruent to EC. And that's what a midpoint does. It divides a segment into two congruent segments. That's definition of a midpoint. Definition of a midpoint. Okay? And that's going to give me a side. Let me mark that. And then I also know I've got vertical angles here, don't I? So we'll use our good old vertical angles are congruent theorem. Sometimes it's called the vertical angle theorem, but we can just state it. And I can say that angle ACB is congruent to angle ECD, and that's vertical angles are congruent. Or you could say the vertical angle theorem, but that's basically straight out what that is. And that gives me an angle. And then I also use my next given, or my second or last given. C is the midpoint of BD. So if C is the midpoint of BD, that means that it divides BD into two congruent segments, BC and DC. So I can say that BC is congruent to DC. All right? And that's, again, definition of a midpoint. That's what a midpoint does. It divides a segment into two congruent segments. And that's my third part that I need. And remember, we just need 3 parts to show the triangles are congruent. In this case, side, angle, side would work. They have to be a special 3 parts. Okay? Remember, it could be side, 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 angle, side, angle, angle, side, or hypotenuse length. Those are the 5 ways. So in this case, we've got side, angle, side, angle, side. So now we know these two triangles are congruent. So I can say triangle AC. Well, let's go ABC this time. Triangle ABC is congruent to triangle. Now, ABC, I got to be careful. ABC. So I'm starting from the angle I want to prove, and I'm going down and then 2. So no side, then 2 marks. So this angle, no marks, then 2 marks. So it would have to be EDC. And that would be side, angle, side. Okay? Now, since that's the case, I know the corresponding parts are congruent, and angle A, and you can see angle A is right here, and angle E is right there, so they're corresponding, just if we look at that notation. So angle A is congruent to angle E, because they're corresponding, A and E, right there, they're both the first spot, and that would be corresponding parts of congruent triangles are congruent, or CPCTC. There you go. All right, and then number 6. Given BC is congruent to DC, AC is the bisector of angle BCD. We want to prove that AB is congruent to AD, so where's next that? AB is over here, and AD. So we want to prove that these segments are congruent. So again, we want to show find two triangles that they're parts of, and they're both parts of these two triangles. So if we can prove these two triangles are congruent, then we've got it. So let's try to prove these two triangles are congruent first. And I've got AB is congruent, BC is congruent to DC, that's given. So I'll put a mark there, and that gives me a side. And then I have that AC is the bisector of angle BCD, that's given. But if it's an angle bisector, what does an angle bisector do? It divides the angle into two congruent angles, so I can say, therefore, angle BCA is congruent to angle DCA. Okay? Because AC is the bisector of angle BCD. All right? So BCA is congruent to DCA, and that's definition of an angle bisector. Okay, angle bisector. And that gives me an angle, so I'm going to mark those angles. And that's an angle. And then we've got our good old reflexive property. AC is congruent to AC. Excuse me. AC. So segment AC is congruent to segment AC. And that's a reflexive property of congruence. And that's going to give me my other side. So now I've got side, angle, side. Side, angle, side, side, angle, side. So now I know that these two triangles are congruent. Just have to make sure I write the congruence correctly. So I'll try ABC. Again, that's nice, alphabetic order. Triangle A, B, C is congruent to triangle. Now I've got to be careful. A, B, C, I want no mark, one mark. So no mark, one mark. A, D, C. And that's by side, angle, side. So you can use these little marks to help you get the right correspondence because they represent corresponding parts. And that's going to be side, angle, side. And if that's the case, then I know that AB, and I'll notice that AB are the first two letters and AD are the first two letters. And I know that AB and AD correspond to each other, and they're going to be congruent because corresponding parts of congruent triangles are congruent. So we'll say that AB is congruent to AD. Why? Corresponding parts, congruent triangles, congruent. Right? CPCTC. And there you have it. All right? So we're doing these is just one more step, one extra step beyond the problems we were doing in section 4.4 and 4.5. Okay? So I hope that makes sense.